I am recording, great. All right, welcome to the last video of week one. So this week we have done our pretest and we have fully started on assignment one and it should be finished at this point. It will be due on Friday, September 4th. And in this video, we're going to go over it. Now, before I start, at this point, you should have completed your pretest, your Unit 1 pretest, about 15 questions, just to give me a vague idea of where you're at in terms of understandings. It will not negatively impact your grade, unless it's the only grade I have for you. So it is. So do be sure to turn in assignment 1. That way, Unit 1 does not count as an actual grade. So let's look. Assignment 1, reading. Obviously, the first thing you do is read the instructions. So we're going to read pages 40 through 45 in this PDF or in the HMH website. Then complete the questions in your evidence notebook. Remember to share those notebooks with me to my email at adeepsami.azad@leusd.net. And don't plagiarize. Again, very obvious. So if we click this PDF either here or the view, I'll press the view because it opens up a new link. Minimize the size of this thing. I'm going to scroll down to page 40. 10 pages in. There you go. We're starting with the study of chemistry because it is the start of the year, and I want you guys to know what chemistry is about. Now, let's take a look at our notebook so we could get started here. Assignment 1, read pages 40 to 45, then complete the following. It's aligned with learning target 4. We click this blue thing, we'll have a nice little pop-up happen. So we have learning target 4, you get T, and that's what it is, and these are the rubrics. So continued mastery, you completed all 7. Proficient, you have number 7 left out, 5 and 7 left out, etc., right? So I have your student edition opened up. We're not going to use that. We'll be using my edition, the answered edition. Now, what is chemistry? Chemistry is typically divided up into 6 or so major categories, but in general, the study of chemistry is the study of matter, aka the entire universe, or everything in it, right? Matter is stuff we could hold and feel. It's the world around us. It's the air that we breathe. It's pretty much everything. Now, things like antimatter and strange matter do exist, and the chemistry does study that, but kind of prohibitively expensive to start that up in a high school. So we're not going to do that. Now, we have chemistry, those 6 different versions. We have physical chemistry, analytical chemistry. Those 2 are typically graduate level chemistry classes. Theoretical chemistry, which I assume a chemistry major would cover. We have organic chemistry and inorganic chemistry, which is something a bio major in undergrad would cover, and biochemistry, which is kind of the newest branch of chemistry. Organic chemistry, inorganic chemistry, and biochemistry are very standard classes in anything related to medicine. It's kind of just foundation level stuff. So might be a good idea to remember those things. Organic chemistry is a study of carbon-based compounds, and you'd be surprised at the amount of stuff that means. You have inorganic chemistry, which is everything organic chemistry isn't, and biochem, so it's focused on living things. Now, we have our first vocab word. These are spread throughout these assigned pages. We have the vocab word for model, a pattern, plan, representation, or description designed to show the structure of workings of an object, system, or concept. Now, we're going to take that, so we'll just go ahead and copy it. The definition really is just that. It is pretty standard, and this is something that I would copy and paste, right? So copy it and paste it up into number 1 for our vocab word. We only have to complete numbers 1 through 5, and here is a good way to start on our first assignment. We have our vocab words 1 through 5. We're going to be taking the vocab words for model, system, criteria, constraints, and trade-offs. So I've already done that prior to this video. Now, for this assignment, I want the vocab words completed, but I do not necessarily need the similar term or phrase. This is something that would be remedial in nature. So Do not complete the similar term and phrase, not necessary. But do have an example for model, an example for system, an example for criteria, constraints, and trade-offs. It could be a picture or a sentence. Now, the example for model, let's talk about it. We have a plan, a representation, or description of an object, system, or concept. Now, that is a very broad definition. It is that way on purpose. So, an example of a model could be literally anything. Let's think about our government, right? Let's say a republic. A republic is a model of government, right? Not necessarily using the word model inside my example because it's not necessary. A republic is a form of government. And that's a good example, right? We have a plan, representation, or description. In this case, we have a description of an object, system, or concept. So the thing we're talking about right now is system. We have a description of a system. A republic is a form of government. That's pretty much what we need to know about republics, and it's a solid example of a model. Not necessarily using the word model in there, but it can if it needs to. Next up, we have system. A set of interacting, interrelated, or interdependent components that form a complex whole. So anything could really be a system if we apply it hard enough, and I do want you to be thinking like that. Think broad, right? A system could be anything. It could even be a laptop, which is what I'm typing on. Laptop, a heart, a bone, right? These are all systems because they are made up of interacting, interrelated, or interdependent components. A human body is a system. So I'm just going to leave it at laptop. Criteria. Goals that tell whether a solution is successful and how efficient and economical that solution should be. In this case, an example of a criteria would be like a rubric that I post. Here's on sets for here's assignments. That's an example of criteria because to meet my rubric is to meet my goals that tell you whether your assignment is successful and how well you did it. So rubrics are a solid model or a solid example of criteria. Constraints. Limitations of a design, the limitation of a design that are often, but not always, provided by the client. So in this example, we have Tony Stark's dad saying he's limited by the technology of his time. He would love to build a new element if he could, but he can't because technology doesn't exist yet. The architecture does not exist yet. And last word, we have trade-offs, an exchange of one thing in return for another. So whenever we set priorities, we are creating trade-offs, right? So the solid example for that would be prioritizing English over Chem because English is harder than Chem, right? And so this trade-off will mean that your English grade will be good while your Chem grade might suffer. But you thought about it and you considered English as having a higher priority, you set that criteria. And so trade-offs are truly juggling priority or trying to juggle criteria. Now, all of that was done without looking at the book. But I'll let you know that the book does have those definitions and solid examples of them. It even breaks the system down into several different parts. So we're gonna stay on this page for a bit because the next thing that we're going to talk about is systems. Now, we know that systems are interrelated, interdependent, or interacting components that form a complex whole. And here we have a few examples that the class has thought up of. We have a PS4, sink, computers, a lamp, cat treats. Pretty much anything is a system, right? And those systems are either open, closed, or isolated. So what do those mean? Let's take a look at the book, zoom in a bit so you guys don't have to struggle with the YouTube. We have an open system. Energy and matter flow in and out freely, right? Like your lungs. Lungs are a pretty open system. Energy and matter flows out. the matter being air in this case. Closed system, there's little or no exchange of matter within the environment, but energy may be freely exchanged. In that case, think of like a battery, right? No matter is really going anywhere, but the energy does move around. In an isolated system, no matter or energy flows in or out. Think about something in a vacuum, right? Not like a vacuum bag, but more like a spaceship, right? Nothing goes in or out, because if it did, you'd have a problem. Now, for number 2, what you'll be doing is thinking about systems and thinking about whether or not they are open, closed, or isolated. And if they are one of those things, tell me how the matter and energy flows in that system, flows around in that system. For cat treats, they're a fairly isolated system, right? Cat treats are composed of multiple things, right? You got animal stuff that cats would like, probably some catnip to keep them addicted. And this system doesn't have any matter that is going out of it, doesn't have any energy flowing out of it or into it, it just kind of is there, which means that it's an isolated system. Nothing is going in or out because nothing's happening to it. The cat hasn't eaten it yet. If the cat ate it, and then we could be talking about whether or not it's an isolated system. Another lamp. A lamp is a closed system because heat is being released through the bulb, and that is thermal energy, and electricity is entering through the plug. So that's where that energy is coming from. No matter is coming out because light technically is not matter, and no carbon dioxide is coming out of the lamp, right? It's not a lantern. So a lamp is a fairly good example of a closed system, right? The only things coming out are electricity and thermal energy. Or the only thing going in is electricity, only thing going out is thermal energy. Computers are fairly good examples of open systems. We have matter that can go in and out, right? Computer CDs, floppies, USBs, those could go in and out of a computer. The power cable supplies electricity, and that electricity exits the computer through heat sinks, typically on the bottom. And so it's a fairly open system, so on and so forth. So think of any object and think about what is going into and out of that system. So for number 3, why is defining systems important in chemistry? This is something I want you to think about. Really give it some thought. That's why this question I'm leaving blank, because I want to see your thoughts on this. Why do you think defining systems would be important in chemistry? A solid hint is located up here or down here with the synthetic gas production. But at the end of the day, it is your thoughts I am interested in. So we're moving on to number 4, the engineering design process. That would be page 42, I believe. Yep. The engineering design process is part of NGSS. We're moving away from the scientific method with its hypothesis, procedure, experiment, conclusion. It's a very rigid process. We're focusing more on engineering design process because at the end of the day, with an engineering process, we have a product at the end. And so for the next 3 pages, we'll be talking about toothpaste as a product, right? For the engineering design process, we're talking about 3 different phases of the entire process. We have defining and delimiting the problem, we have designing solutions, and we have optimizing those design solutions. Now, what are the 3 main parts? Well, I just named them. But the thing you have to look at is summarizing them. I have them summarized here, and I'll go through about them. So to define and delimit a problem, to define a problem is to know what the problem is. You got to identify it. Fairly straightforward there. To delimit the problem, though, is where most people get caught up. Now, to delimit a problem means to think about a problem in terms of criteria and constraints. Criteria are the things you would like your solution to have, right? If my problem is I need a better toothpaste, well, I would like my toothpaste to be very clean. I like it to look nice. I want it to feel nice. I don't want it to like look ugly. Those are my criteria, right? My constraints, on the other hand, are the things that will hold me back. If criteria push me forward, constraints hold me back. They're the boundaries, right? I can't pass go. So for as far as constraints go, most of them will boil down to they can't be too expensive, right? My design can't be too expensive, otherwise what's the point? And my constraint could typically be like other things, like it has to fit in this kind of bottle, it has to be a certain size. Those are constraints, not exactly criteria. So to delimit a problem is to set criteria and constraints. To design solutions, you have to be able to create solutions that meet those criteria and those constraints. So over here we have most important criteria. We're going to talk about what that means in a second, because you're designing multiple solutions, right? There isn't, what's that phrase? There are plenty of ways to skin a cat, right? It's a pretty weird phrase if you think about it, but it gets the job done, right? There are plenty of ways to solve a problem, right? What was the good old story about NASA? NASA spent millions of dollars trying to develop a writing instrument that could work in space. They poured millions into ink, uh, pen designs, paper designs. They poured millions of dollars into this research and development. And the Russians looked at the Americans, were like, why don't you just use a pencil? And now you might think that's funny, but what America knew and what the Russians didn't was that the graphite inside pencils could fry a electrical board, whereas their specially developed pens won't do that. So at the end of the day, Americans got to the moon and Russians did not. Now, we had to design solutions, and then as we optimize them, we had to consider our trade-offs, right? We have to look at our criteria, and if we're talking about toothpaste, we have to consider what is my most important criteria. You guys do something like this every day when you're talking about class, right? What is my most important class? What do I really need to focus on? And what can I let fall to the wayside? For most of you, it's typically electives that fall to the wayside, but that's your trade-off, right? The GPA slips because you've decided this class needs more time, whereas this class I could kind of get away with. So you got to optimize solutions, and to do that, you consider those trade-offs, right? You consider your most important criteria and you put them in a priority order. We've talked about this earlier with the vocab words. Now, defining and dealing with a problem does have its own little section here, and that's why I recommend highly to read the entire article, even though I'm going through the answers here. To define and delimit a problem is what we're going to focus on. But number 5, we're specifically talking about that, defining and delimiting 2 of those scenarios. I'm only going to do one of them and let you do the other yourself. And in class, we did the drama class because I felt as if it's something a lot of you can relate with, because it is something can relate with, right? Could possibly relate with. We do have a drama class at Canoga. Big recommendation to attend it. And so, to define a problem is to know what the problem is. And so a drama class needs to construct background scenes for a play. Well, what's their problem? They need to make background scenes. Right. And to delimit a problem is to think of the problem in terms of criteria and constraints. And now what I'm asking you to do is to set up criteria. If you wanted to solve this problem, how would you go about doing it? Well, for my case, to make a background scene, let's think of it. I want it to be colorful. I want props. I want lighting. I want extras. Those are the people that walk around in the background, trying to make it look kind of active, right? I want sound, right? Music, maybe. What else do I want? I want, I don't know. Let's say I want paint, right? I want it to look really shiny, et cetera, right? These are all things I would like my background to have. What are my constraints? Well, the constraints is that the size of my stage is very limited. Size of stage is limited. What else is a major constraint? Well, the budget is always a major constraint. Now, budget is always something that applies to pretty much all problems. Budget, if you're not a major world government, is something that you're always going to be thinking of. And so because of that, I don't want you guys to be thinking of budget as a singular thing, right? So instead of doing that, strike that through, I want you to think of budget in terms of what do you use the budget for? Well, we could only hire so many people, right? Hiring laborers, right? The stagehand, the sound producer, a lighting director, right? So there's so many things we could use budget for, right? We're limited to 3 cans of paint, right? We've got 1 piece of plywood that we could use. So you've got to be able to do a lot with a little, right? If you ever saw the play Hamilton, it's on Disney Plus, #ad. If you ever saw that play, you'll notice that their stage is very, very minimal. They hired a bunch of actors and actresses. Their costumes are essentially white, colonial looking clothes. And they have very few props. They maybe have 1 table and a few blank pieces of paper and a quill. That's all they have as far as background design goes. A lot of their budget went into lighting and sound design, right? And you could tell based on the quality. They also went into actors and stagehands. So a lot of the time, you have to prioritize what you want. In this case, let's say for Hamilton, they didn't prioritize props, they prioritized lighting and sound, because at the end of the day, it was a musical. So of course, sound is very important. So those constraints are things we thought of ourselves. They don't necessarily have to exist, but they can. Now, that's what you'll be doing. For criteria and constraints, you are setting them up yourself, right? Imagine. Now, back to our toothpaste example. Let's say we want to set up some criteria and constraints. We're looking through and we're deciding which is which here. The stripe should be visually aesthetic. It should be appealing. That is definitely a criterion. The criterion, by the way, is the singular form of criteria. And so this is definitely a criterion, right? Something that we want our toothpaste to have. We want it to be visually appealing. Next up, the stripe should be below a certain cost. Well, here we're thinking about budget, and if we're thinking about budget, that's certainly a constraint. We're being limited based on our cost. We can't make that stripe solid gold, unfortunately. The chemicals in the blue dye should not react with plastic tubing. Now, should typically means a preference, but not reacting with the plastic tubing, that's a pretty solid constraint, right? One, if we had toothpaste that did react with our plastic tubing, we would have to redesign our toothpaste or our plastic tubing, and that is going to run up against our first constraint. So because of that, this is also a constraint, right? We have to dig deeper and we have to think deeper. The blue dye cannot cause the toothpaste to foam blue. This sounds like a preference, right? Because while it can foam blue, there are definitely children's, toothpastes that are preferentially foaming blue. So this is not a deal breaker, right? This is something you could redesign if it doesn't come out that way, if it doesn't come out the way you'd like. And finally, the mint flavor has to be refreshing, but not too strong. This is essentially a criterion because refreshing is a very subjective term, right? It changes based on the person. Too strong also changes based on the person. So it's definitely a preference for a given value of person. Now we have set up our answer for number 6, and we're ready to get to number 7. Either by yourself or a partner, think about some criteria that are important to you when making a product like toothpaste. What trade-offs might you consider making to ensure your most important criteria are met? Now, for this question, I don't really mind if you go back and pick any of the other times you've set up criteria and constraints. For this case, though, we already have several criteria for our toothpaste, so let's look. The stripe should be appealing, it should not foam blue, and the mint needs to be strong or refreshing. Now, what we're doing here for number 7 is deciding trade-offs, right? What do we prioritize and how would we do that? What trade-offs might you consider making to ensure your most important criteria are met? Like a soldier on a battlefield, you have to make priorities, right? It's like triage. There are so many places where trade-offs are considered. In the medical field, we have triage, right? That's basically saying that this person will survive, so we're going to dedicate some resources to him. That other person is not going to survive. They get nothing because we have only so many supplies. Let's see. A recent example of this would be in, oh, it's not recent. During 9/11, resources like water, hospital beds were in critical supply, critical demand. And so those beds were given to people who were likely to survive. If you were not likely to survive, I'm sorry, but you kind of just got left out. And that happens all the time in the medical field. Organ donations are given to people who are likely to live longer because the trade-off is if you give it to an 80-year-old person, that 80-year-old person is going to possibly die because of the surgery itself. And if they do survive, they probably have 5 more years, 20 more years left, whereas that 30-year-old would have 60 more years. Very direct trade-off. There's actually an equation to decide who gets what organ when. Now, back to the toothpaste. Aesthetic, no flowing blue, refreshing mint. So what trade-offs might you consider to ensure your most important criteria are met? What you're basically saying is that, and this is completely subjective and it is subject to change based on your own preference, but for me, I would say that if I want my stripe to be appealing, Control Z, Control Z, here we go. I want my toothpaste to be visually appealing and minty, fresh. And so the trade-off is, so I would be willing to have my paste foam blue, right? That is my most important, those are my most important criteria. And if it means that my foam or my toothpaste is gonna foam blue, I take it. My trade-off is there, right? I've set my criteria in order of priority, and I'm willing to accept a blue foam. That is a trade-off, and that is essentially how you would answer this question. You're considering what trade-offs you might make to make sure your most important criteria are met. Now, your most important criteria means that it differs for every single one of you students. Or it might not. Some people like similar things. That's why ad industry is a thing. But that's where I'm going to end for today. That is assignment 1, gone over and reviewed. It is due September 4th, 9/4, that is Friday. So be sure to have your assignment filled out. Be sure to have this assignment filled out. I'll be going ahead and commenting on them on Friday. So I hope you have a great rest of your day. And I'm going to stop recording. Bye-bye.